right, so this is the last theorem of this lesson, segments of secants and tangents. So now we have a secant segment followed by a tangent segment. So here's what the theorem says. We're going to take the portions of the secant like we did before, the outside, EC, times the entire length, ED. And now when we get to the other one, it's a tangent. So the outside is EA, but the entire thing is also EA, and that's how they get EA squared. So it's essentially the same theorem. It just looks a little bit different when you go to do the simplifying. Okay, so let's apply it to an actual problem here. In this one below, we're going to do x times the entire length, which is x plus 8. So I'm going to write that. So x times x plus 8, and that's going to equal 16, which is the external portion, times the entire thing, which is also 16. So that's where we get 16 squared. Okay, let's do a little bit of simplifying. Now I can tell you we're going to end up having to do the quadratic formula here, and we haven't done that in a while, so it's good practice. This is what we get though. We can see there's a quadratic of some form. If I go ahead and get everything on one side, this is what I find. Now if I try to factor this, I could give it a go. Factors of negative 256 that add to give me 8. It's not factorable. So let's review the quadratic formula. Maybe you had memorized it last year to a nice little sing-song, but it is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, good work. So now let's sub in those values. It's going to be negative 8 plus or minus the square root of 8 squared minus 4 times my a is 1 and my c is negative 256. Now all that's over 2a, so 2 times 1. Okay, so negative 8 plus or minus the square root of, inside I can work through all that. If you remember, that value inside is called the discriminant. So 8 squared is 24. Minus 4 times negative 256. The negatives cancel and we get 1088 all over 2. So I really have 8 plus the square root of 1088 over 2, and I have 8 minus the square root of 1088 over 2. Okay, all right, so I'm just going to do that first one. 8 plus the square root of 1088, get an answer and divide that by 2. And I get, let's see if I type that in right. Okay, yeah, so, sorry, I typed something wrong, so I just wanted to make sure I had it right before I said it wrong. 8 plus the square root of 1088 gives us 40.98, I'm not going to delete that off my calculator, I'm just going to divide that by 2, and my final answer is 20.49 rounded to the nearest hundredth. For the second one, whenever I go to do 8 minus it, I end up getting a negative number. But I'm still going to write it down just for right now. It's negative 12.49. Okay. All right. So looking at my answers, I can't have this be a negative length. So this one's out, and that means my answer, my value of x, is going to be, I can round that. Let's erase all that. I can round this and say that it's 20.49. So when they want the entire length of RS, that's my answer. I don't add anything else to it. RS is going to be 20.49. Now that one was involved, but only because we had to use the quadratic formula. So let's try one that's not quite as extensive. Here, find the radius of the aquarium tank. So we have a cylindrical tank. We're looking at it from above. That's how I'm looking at it, I guess. And they want us to find the radius of this tank. So they've gone ahead, and this is where like this applies. I know you're not going to go ahead and find the radius of a tank like this, but it's a scenario where you're given something and you have to find an unknown, and that's where recalling these theorems, which I understand most people aren't going to do in their daily life, but it's training your brain to be able to recall things and problem solve and think through this stuff. So whether you actually apply this particular theorem at some point in your life or not, it's just that practice of not just reiterating information, but being able to use it in a given scenario. But first we have to learn what the information is. So off of that, we can say that it's going to be 20 squared. It's going to equal the outside portion here, 8, times the entire length, which is 8 plus r, so 8 plus 2r. Okay, so 400 is going to equal 64 plus 16r. This one only has one r, so I don't have a quadratic. I'm going to go ahead and subtract 400 minus 64. I'm going to get 336 equals 16r. And when I divide by 16, r is equal to 21. And that is what they want us to find, so I can label that 21 feet. That's my answer. Okay, let's practice setting up this next one. I'm going to say this outside portion x of the tangent, so it's just x times x or x squared, equals this outside portion times the entire length, which is 4. So x squared equals 1 times 4, or 4, so x equals plus or minus 2. But I can't have a negative length, so x only equals 2. Okay? All right, this one, 7 squared is going to equal 5. The outside portion, the external segment, times the entire length, 5 plus x. So 49 equals 25 plus 5x. I'm going to go ahead and subtract 25 on both sides. I get 24 is equal to 5x. Divide by 5. And I know that seems like it might be wrong, but that's okay. We did everything right. 4.8, good answer. Okay, and you can always sub it back in and check and see if they equal. So does 5 plus 4.8, obviously 9.8, does that equal, if I multiply that by 5, does that equal 7 times 7? And it does. All right, our last one here is we're going to go ahead and set up 12 squared equal to x times x plus 10. All right, so we have 144 equals x squared plus 10x. Oh, we have a quadratic set up here. So x squared equals, oops, let me reset. I'm going to have, instead, x squared plus 10x minus 144. I'm going to see equals 0 if that's factorable, and this one does not appear to be the case. So my a is 1, there's a 1 here, my b is 10, and my c is negative 144. So another quadratic. So x equals, I'm just going to write it, negative b plus or minus the square root of b squared minus 4ac over 2a, which turns into negative 10 plus or minus 10 squared minus 4 times 1 times negative 144, all over 2 times 1, or 2. I'll put this over here then. All right, so negative 10 plus or minus, and 100 is 10 squared minus 4 times negative 144. Actually turns out to be 676. All right, and that is a perfect square. It's 26, so that's going to be really nice. So this is going to turn into negative 10 plus or minus 26 over 2. So if I break that into my two categories, and I'll write in blue because we're getting close to the other color, I can do negative 10 plus 26 over 2 and negative 10 minus 26 over 2. Negative 10 plus 26 is 16 over 2, which is 8. Negative 10 minus 26 is negative 36 over 2, which is negative 18. And when I look back at my problem, negative 18 would imply that I have a negative distance, if I can get back there right here. So that one's not going to apply, and so my answer is 8. And they're just asking for the value of x here, so x is equal to 8. Okay, all right. Let's just finish it up. One last thing, we're going to take a look at why this works. Similar reasoning as we saw before. See, I tried to make sure I wasn't missing a factor. And let's go to this. All right, so here's our setting, our scenario, when we have a tangent and a secant segment. Oh, clear. There, oh, wrong button. Okay. So if I look at this, here's my tangent segment, here's my secant segment. Okay, so they go ahead and they draw in two extra lines, and this is kind of unique for them to think about doing that, but when they draw in these two lines, we've created two triangles now. And they end up concluding that and you can see here this theorem, that this arc and this arc, or those two angles, I'm sorry, this angle and this angle share the same arc. So they have this common intercepted arc, so that means those both have the same value. Okay, so that gives us the fact that these are going to be congruent right here. And then we also have that angle C is congruent to angle C. And so we have two that we're able to work with here. And they, again, so they say triangle CAD is similar to triangle CDB. Okay, similar just means same shape, different size, obviously. And then they can make a proportion that AC over DC is going to be equal in value to DC over BC. Oh, just this little piece. Okay, so they did the long over, it's hard because we don't have a right triangle to say short leg, but it would work out if we would draw them out. But I'll spare you that. You can try it on your own. But anyways, you cross multiply and you find what we did there. Okay, so just a little background on why it works. If you are curious, feel free to always ask me if there's anything you're not sure about, and I will see you soon.